Welcome to my channel. Yesterday we discussed about the relation between Cartesian and polar coordinates. Today we will solve some problems related to the Cartesian and polar coordinates. Here a question is given that change the Cartesian coordinates to polar coordinates 2, 2, minus 3, 1, minus 1, minus root 3, 2, minus 2. Now we will solve the problems. Here the Cartesian coordinate is 2, 2. So here we get that x equal to 2, y equal to 2. Now we know that r equal to root over of x square plus y square. So here putting the values of x and y, we get that 2 square plus 2 square equals to 2 root 2. Now we have to calculate theta. Here theta equals to, we know that theta equals to tan inverse y by x. So putting the values, we get that tan inverse 2/2 equals to tan inverse 1 equals to pi by 4. We know that tan pi by 4 equals to 1, so that tan inverse 1 equals to pi by 4. Why here the angle is pi by 4? How do you know that this angle is in the first quadrant? It may be on the third quadrant. So here is the rule. We have to check the points. Why is the point? Here 2, point is in the first coordinate. Here 2, point is in the first quadrant. So the angle will be a angle in the first quadrant. So the polar coordinate of the point 2, 2 is 2 root 2, 5 by 4. Now we will solve the second one. Here the given point is minus root 3, 1. So here x equal to minus root 3 and y equal to 1. We have to check what the point is. The point is here x coordinate is negative and y coordinate is positive. So the point will be in the second quadrant. We know the angle in the second quadrant is between pi by 2 and pi. So the theta here will be between pi by 2 and pi. So we have to calculate r at first. Here r equals to root over minus root 3 whole square plus 1 square equals to 3 plus 1 equals to 2. Now we know that if the angle is in first quadrant, then it is theta. If the angle is in second quadrant, then the angle is pi minus theta. If the angle is in third quadrant, the angle is pi plus theta, and if it is fourth quadrant, then 2 pi minus theta. Here the angle is in the second quadrant, it is in second quadrant. So here theta equals to tan inverse 1 by minus root 3. That is, it is in second quadrant, so pi minus theta, pi minus tan inverse 1 by root 3. That is pi minus pi by 6, that is 5 pi by 6. So the polar coordinate of the given point is minus root 3, 1 is 2, 5 pi by 6. Now we will solve the third one. Here x equals to minus 1, y equals to minus root 3. So r equals to root over minus 1 whole square plus minus root 3 whole square. That is root over of 4, that is 2. and here the point is in third quadrant, so the angle will be also in third quadrant. So here theta equals to tan inverse minus root 3 divided by minus 1, that is tan inverse root 3, that is pi plus tan inverse root 3, that is pi plus pi by 3 equals to 4 pi by 3. So the polar coordinate of the given point is 2, 4 pi by 3. Now the last one is now the last one. Here the point is 2, minus 2 and the point is in fourth quadrant. So here x equals to 2, y equals to minus 2. At first we have to calculate r. R equals to root over 2 square plus minus 2 square, that is root over 4 plus 4, that is 2 root 2. And here theta equals to tan inverse minus 2 by 2, that is tan inverse minus 1, that is 2 pi minus tan inverse 1. Here the second tan inverse 1 is always in first quadrant. 2 pi minus pi by 4, that is 7 pi by 4. So the polar coordinate of the given point 2, minus 2 is 2 root 2, 7 pi by 4. I think you all understand the rules of transforming Cartesian coordinate to polar coordinates. Now we will change some polar coordinates to Cartesian coordinates. Here three set of points are given. The first one is 2, pi by 4. Second one is 4, 5 pi by 6. And the third one is 2 root 2, 5 pi by 4. Now we will solve the first one. Here the given point is 2, pi by 4. It is a polar coordinate and the angle is pi by 4. So the angle is in the first quadrant. So the Cartesian coordinate will be also in first quadrant. Now let us check. We know that x equals to r cos theta and y equals to r sin theta. Here r equals to 2 and theta equals to pi by 4. So putting the value of r and theta, we will get that x equal to 2 cos pi by 4, that is 2 into 1 by root 2 equals to root 2, and y equals to 2 sin pi by 4, that is 2 into 1 by root 2 equals to root 2. We know the value of cos pi by 4 and sin pi by 4, both are 1 by root 2. So the Cartesian coordinate of the given point is root 2, root 2. Now the second one. Here the given point is 4, 5 pi by 6. The angle 5 pi by 6, that is equal to 150 degree, is in the second quadrant. So the point also be in second quadrant. Now here r equals to 4 and theta equals to 5 pi by 6. So x equal to r cos theta, that is 4 cos 5 pi by 6 equals to, now we have to find the value of cos 5 pi by 6. Cos 5 pi by 6, we may write it as cos pi minus pi by 6. The angle is in the second quadrant, so cos theta is negative, that is minus cos pi by 6, that is 1 minus root 3 by 2. So that is 4 into minus root 3 by 2 minus 2 root 3. So the x equal to minus 2 root 3. Now we will find the y. Now y equal to r sin theta. So 4 sin 5 pi by 6. Now we have to find the value of sin 5 pi by 6. So sin 5 pi by 6 equals to sin pi minus pi by 6. Now it is in second quadrant. So sin pi minus pi by 6 equal to sin pi by 6. As in the second quadrant, sin theta is positive. We know that in the first quadrant all is positive. Second quadrant only sin is positive. In the third quadrant tan theta is positive, and then in the fourth quadrant only cos theta is positive. So sin pi by 6, that is 1 by 2. So putting the value, we will get that 2. So the Cartesian coordinate of the given polar coordinate is minus 2 root 3 comma 2. Now the third one. Here the point is 2 root 2 comma 5 pi by 4. The angle 5 pi by 4 is in the third quadrant. Now x equal to root 2 r cos theta. So 2 root 2 into cos 5 pi by 4. Cos 5 pi by 4, we may write it as cos pi plus pi by 4. That is minus cos pi by 4. As in the third quadrant only tan is positive, so cos is negative, that is minus 1 by root 2. Also sin 5 pi by 4 equals to sin pi plus pi by 4, that is also negative, and it is minus sin pi by 4, that is minus 1 by root 2. So putting the value of cos 5 pi by 4, we will get 2 root 2 into minus 1 by root 2, that is minus 2. Y equals to 2 root 2 sin 5 pi by 4, that is 2 root 2 into minus 1 by root 2, that is minus 2. So the Cartesian coordinate of the given point is minus 2 comma minus 2. Polar to Cartesian and Cartesian to polar transformation. If you have any question regarding to this chapter, please mention it in the comment section below. In the next class, we will discuss the remaining part of the chapter, that is area of a triangle, distance between 2 points, centroid of a triangle, and the remaining parts. Thank you.